Hello everyone, welcome back to another part of the Shanghai Tower Grasshopper tutorial. In this part of the tutorial, we'll try to focus on three main things to try to finish the top of our tower, which is the crown. And I'm just going to briefly illustrate it with my pen. First off, what we need to do is we need to make that the curve part that this where the maintenance mechanism rest for cleaning the windows, I believe. So that's one part we have to make, and the other main part is of course you have these steel rods going down to a platform in the center. And lastly, we also have another small sort of like this part that folds back into a tower uh, to create, to sort of close off the blue part. So these are the three main parts we're going to focusing on, and which we'll be finishing on for the top of the tower. And then the first thing we're going to do, we'll try to tackle, is going to be the blue part, and then maybe we'll move on to the yellow and then finish it off with the steel rods going down to the center. Okay, to start off, we obviously need some starting parameters. So let's have a look at what we had since our last video. So we have that. We definitely want to have that curve, the outside curve, which we'll try to identify where it is. Well, it's gotta be here somewhere here. It's still a surface. We're getting there. I think this one, yeah. So we can take this one, or we can take the polyline just before that. Well, it doesn't really make any big difference. So in this case, we'll take a polyline. So we'll quickly make ourselves a component here. We'll drag it all the way here. We'll get up a name. We'll call this crown. Wait, yeah, crown edge curve, something like that. And then we'll make a copy. We'll make it hidden. You have to make sure that the first one exists in the group so that it moves along. So we have a first parameter. Now we can actually turn this off, and I'm gonna do something else too, because my mouse needs a geometry to snap on. So I'm gonna quickly bake something in order for me to be able to snap to it. Okay. Yeah, so we have our line. Actually, let me turn this back off. We'll turn this one on so I can easily select it. And the way we can approach this is we can draw, you would assume that we can draw a line that are making the spokes. Let me actually draw that instead of trying to make it into Word. So you could say that, well, let's draw all this with a certain distance, and then we just loft it, right? I mean, yes, that could work. You're just gonna have troubles getting these lines perfectly where you want them to be. So we have to assist, build up a little bit of logic behind that. What we're gonna do is we're gonna try to, since we have the curve and we know our curve are segmented, meaning we can get these points, right? And we can use the center. We can use our P work point number 1 for that, and then we can say whatever point that is closest to the curve, it's going to draw a line. What this will ensure us to do, will give us, is that the line will more or less be uniform because they're looking at the same center. I'm not sure if that makes sense. So we'll try to make that. We'll try to create that, and then we'll go from there. So obviously we need WP01, which I have here. No, I think it's here. Yeah. So I should copy this instead. So I'll do Control C, Shift V, Control Shift V to paste that into here, and to double check that I'm not, yeah, I'm copying from this. To double check I'm not ruining something. All right. So we got a point, we got a line, and I think for this we can do a discontinuity because we know this curve is a polyline. Oh, I just found out we have yet to join our curve. So I'm just going to quickly flatten that part so that we can have one single curve. It's still broken somewhere. Probably, well, let me see where it's broken. It shouldn't be broken. Aha. So around this part, seems like our script is having trouble merging that. I think it might have to do actually with a direction of curve. So I'm just going to quickly identify that. Point on curve, and then we'll quickly do this. Zoom out a little bit. So we got 1, 2, 3 point, and see how they move. Well, they do move in the same direction. So I think it's only a matter of that the points are not exactly touching. There's probably a small tolerance where it just doesn't seem to align. Okay, that's not a big issue. We can solve that. We can actually do an explode here. In hindsight, we might have just better take the explode instead. I think where did we take this from? We take it from here. Yeah. In hindsight, we might have been better off to take this. But yeah, doesn't really matter that now. It's just one component since we're doing the same thing here anyway. One thing we have to make sure is also to we can redraw lines actually. So I'm just going to quickly do a interpolate, not that, an interpolate curve. That is weird. Where is my? There we go. We have to watch out for one thing. Since we exploded this, actually still no wait yeah. So since we exploded this, we have multiple segments where each segment has a vertex to it. So we have double vertices, so we need to clear those first. And I'm gonna use a component. Oh, that's not the one. I'm gonna use a component by Kangaroo. I think this one comes from Kangaroo 2. Yep. So if you have not installed Kangaroo 2, this might be a good time. I assume that everybody already has Kangaroo 2 installed because it's one of those plugins where you will most likely find it in every Grasshopper user's toolbox. Okay, so with that said, we'll just plug in the V. So as you can see, we do have to flatten this so that it can check for all the points. We have 144 points before removing duplicates. After removing duplicates, we have 138. So I'm just going to connect that here. And we have our interpolated curve. And I can show you what you get if you don't do the duplicate line. Well, I'm not even seeing my, well, it just gives me a null because I think certain points are going to be connecting where you form a line with 0 length. So make sure that you remove the duplicate points. So I can actually now hide that and have a nice interpolated curve. Now with this curve, what we can do is we can do an endpoint like this so that we can get the starting end, and we only be using this in order for us to get our points up to the same level where we want them to. So I'm just going to quickly grab the start. We're going to make a XY plane out of it. Same for the end. And since we don't want to mess with the floor height and stuff like that, we'll just quickly do a shortcut, which is project an object onto the plane. So we're going to project the point onto that plane. We're going to do it again for the bottom one. And what we can do now, we can just draw a line between the starting and the end point. So this is a quick way to get the point up to the level where we want it to be without having to mess around with what floor this is and etc. So we can hide that. Now that we have a line and we have our interpolated curve, the next thing we can do is divide this curve into I'm just going to set a parameter from 10 is to 100, maybe like that. We'll see how it goes with 50. And then from this point we can say point closest to curve, point curve closest point. So we'll take that, and we have all the points that correspond here. Now if you want to know how that looks like, we can actually copy our line. We'll start from here and then we end here. So then this is what you'll be getting. But of course, unless you want your tower to have a closed off sort of ramp like this, you could do it like that. I'm just going to hide these points also. So then you can use this to adjust how fine do you want your ramp to be. So I'm just going to leave that quickly to 50 again, so we can come back and adjust it later. That's not what we want, right? That's not what we want at all. What we want to do is we want to have a parameter that sets the length that we want. So I'm going to quickly create a vector starting from here. This is my vector to here. Okay. I don't need this line now. That was just for demonstration, for visual purposes. But instead, I'm going to do a vector display. I'll pick the green one now. From that point. Actually, maybe the red one would be better, because now I'm looking, I can't even see what I want to show. Yeah, I think the red one would be better. The reason I want to do this is that I can use this vector to create my line by using a SDL command that obviously comes from that point over there with the vectors as a direction, and then we can set a length for our lines. For example, we can have let's start off with 1,000 with 1 meter, between 1 meter and 3, I would say. We can hide that. So let's say we have we'll give this a name. We're gonna call this crown depth. Does that make sense? We can call it something else if it doesn't make sense in the end. So that's not to worry about that. Crown depth. We might have to increase this to 5,000, so 5 meters wide. Yeah, something like that will look a lot better. Okay. I'm gonna quickly loft this so that we can already have an idea where we're going with this. So if you loft that, you get something like that. But there's a few issues, actually 2 issues where you have to solve. First one being, if I have to draw it, that this is not connecting, so is the bottom, right? And if I clean that and try to get to a elevation view, you will see that this is actually shooting up instead of being aligned with this line. So we also need to fix that part. So let me clear that. So let's fix the bump first that sort of like goes up. One easy way to fix that actually is to go back into the line that we used to generate the closest point. So I'm just going to quickly move this a little bit. we're gonna do a trim, sorry, an extend that extends negatively, only from one side. So I'm just gonna quickly make a slider. Actually, yeah, we'll just create a slider. We're gonna call this then, we'll just enter 2000 first. Since we want a negative value, we want to have maybe negative 10,000 to 0, so that it goes from negative 10,000, 10 meters to 0. And then we're going to call this, well, it's to fix the bump, so we're just going to bump adjust. And then I think the L0 is the start, so we're just going to right click here and put 0 because we don't want to change anything there, so that one is fine. We just want to change the L1, which is the top. Now observe what happens if I increase or decrease it. See how it sort of moves down? And what we can do now, we can fix that line here and adjust accordingly. So for example, if you watch this top curve right here, watch how it changes when I adjust these. See how it sort of like flaps down and flaps upwards. So I think if you go down something like minus 6,000 would be a nice starting point, since that's where it sort of like dips down to the highest but still maintains a sloping effect. You can do the same thing also for the bottom, or you can apply some more smoother, oops, sorry about that, a smoother operation if you want that to smooth your ramp a little bit. But I think we're okay with this, and actually we're going to call this the density. Yeah, let's say, we'll give it 100. It's not that heavy in terms of computational power, so we can start with that. Okay. There's also one thing you can do. You could have, instead of making these lines, which doesn't align with the part, if you want those to align, you can actually take your points and project them onto this curve, and then use those curves instead of generating a points divided from these from the division of this line. Both is doable and doesn't change that much, because there's not really need to form a relationship between the line where they stop and the ramp. But of course you're free to do so if you really want to, if there's any specific application that you would like to do for that. But yes, so I'm just gonna quickly get this off. I don't need to see that anymore. So we fixed the first issue. Now we need to fix that issue, and for that we need our curve. So I'm just gonna quickly see. Yeah, so this is how by far we're gonna quickly get that curve from a previous script, see if we can get it, and at the same time we're gonna get the top curve and then have those two join together. So I think we have to go back now to the V-strike, and top of my head, I think the V-strike we put it here. Yeah, exactly. But we also did a small culling over there to get rid of that part. So I'm not sure if we can still grab it from a later stage around that part. Well, we can definitely grab that one from this or that. Anything else actually? Yeah, no, that's fine. We'll grab it from these two. So we're just gonna copy that. And the way I copied is you select it, press Alt once, and then release. I only need two. I'm just gonna click here, and then hidden. Call this hidden. Yeah, we don't need to see it since it's gonna be here anyway. I'm gonna place it around here. So for starters, we're gonna grab the top one first, or the bottom one, whichever you prefer. We have to do the same thing anyway. Alright, so what we can do now to identify, we know the way we set up the script originally. The top one is going to be the last branch. So what we can do is we can do a tree stat like that. and we're gonna do a split tree in order to isolate that part. So we're gonna make a list item first because we want to select the last branch. And by using a reverse on the list, we're able to select that. So we want to, for the sake, since I'm not sure if we've simplified this in the beginning, we'll just simplify this just so our branches is gonna be one level. So we put that into D, we split that like this. We can now hide that, but we don't need to see it. So we have our last branch. Now only thing we need to do is to find that curve. So I think this is now into 8 surfaces exactly. Can we convert? Yeah, we'll just work with that. Okay. We also know that these panels are separated in a way where it starts from left to right. So we can do a split list just so we can split those 4 that we want. I'm just going to quickly do a split list. And since we're not sure, I mean, we've set a parameter somewhere that we have 8 items with 8 panels in the groove, right, in a V-stripe. But since we don't want to set this here as a static value, we're just going to say, okay, take the amount of numbers you have there, which is always going to be 8, or however many panels you have, and that panel or that number divided by 2. So you can split your list exactly in half. So if you do a geometry from A or B in this case, then we have the panel selected that we want. So the last thing we're going to do is just going to do deconstruct, and we need to select the top curve. So we're just going to quickly do a very rough sorting process. So we're going to evaluate this curve in here. We parameterize it, select the middle point or any other point. We don't really mind, but the middle point will be the best one as long as it's not the first and as long as it's not 0 the end points. Because the logic what we're going to do is we selected, what did I set? Oh, 0.5. Yeah. The logic behind this is the point with the highest z value is where the curve should be where we want to select. So we're going to quickly do a deconstruct the points so that I can get the z value out of it. You can always do this in one single evaluator, but that gets well, for something as simple as this, we don't need that, to be honest. So we're going to sort this quickly and synchronize that with those edge, so that when we do a list item from that and reverse this, we'll always have the top curve. The only thing we need to do now is to say join this curve. We'll also need to flatten this, obviously. Then we have our curve, and we can just disable that. If we zoom back in, you see that we have that curve. All right. I think in the end, if we were to join this or loft this might look very ugly, to be honest. We have to see how we're going to tackle that. So that we have our lower one. For the top one, let me see what we have here. We can actually do roughly the same thing. So I'm just going to quickly grab these two and split that accordingly. Yep, so we have the top one. Yeah, I think it's basically all the same thing. So it's just going to quickly do this instead. So we have the top curve. Or why do I only have 2? Oh, because we don't need to split the list because there's already 4 items, so we can get rid of this, get rid of that, and just plug that one here. We'll leave it here so we know what we did. Okay, so then we have that part. We have both our curves. So let's try to see what happens if we try to merge this in here. Now a normal merger Not sure how this will work because I know my experience with the merge, the normal merge, is that the ordering is not always guaranteed. For example, if I say, all right, you go here first, and then this one, it could might as well work. And then we loft this, yeah, then we get a kind of weird ordering because of the data tree that's still in here. You see. So I'm not sure if I flatten this, yeah, it's not going to solve anything. But what I instead suggest is if we use an entwine, right? Where you can say, all right, the first one's going to go there, the second one's going to go here, and then the last, and then you flatten the output. Oh, you still don't get. Why is that actually? Love cannot be constructed. Well, that doesn't really help me at all. But let me try to see, because I think it might have to do with that these are actually touching. But let me first check how the curve is orientated. So we got from here to here at the bottom. The top one might have to be flipped. So I'm just gonna flip that just in case. Still not resolving our issue. So in the end, oops, not delete. So in the end, I think we might have to get rid of one curve there and one curve there. So that's easy to do. So we just do a double culling. So we say you call off the 0, reverse, reverse. We'll do another again. This time get rid of the reverse so that we end up with curve without that one. So we plug that in here. Oh wow, this is quite interesting. Oh wait, I need to get rid of the reverse, obviously. There we go. We actually don't need to flatten. Okay, there we go. We got a loft that's it looks pretty okay actually. What happens if I do this though? Yeah. So that happens. So you have to either make sure that your length is the same as the length of the curve, which you can just say length of this, plug into here, and then you don't have to worry about adjusting the length anymore. How much is this actually? 4447. So if you plug that in here, you always have something that's uniform, so you don't need to adjust the length. So that length will then be automatically adjusted when you play with how deep you want the groove to be. So maybe that's better, so we'll just leave it at that. This kind of looks stand out so that we know that if there's something else, this will stand out, and then we can adjust that accordingly. All right, that's part one of the 3 main topics we're going to tackle in this video. So we're going to now briefly move to continue on with the yellow part, which is the backfold. To make the backfold flap, we first need to identify how many floors. How many floors the will still go down, because we know that the flap, if I have to draw it here now, it goes actually to this floor, and then it makes another I believe goes down even more, something like this. So it has a little bit more depth than what you can see that is from this floor, if that makes any sense. So first we need to identify how many floors does it still go down from the point where the V-strike gets halved, you know. So let me clear this first before we do that. Okay, and we have done that because if we quickly scroll back and look at our core, which I think is this one. Yeah. So this is the core. I think we actually have to also reduce the core in order for us to get the extra floor that we wanted. So I'm just going to quickly introduce actually a new parameter here. Where is the floor? Let me sort this like that. So we have floor height, top scaling, Swiss angles, start, crown, floor. Yeah, so I guess if I were to copy this crown floor below, so this is going to be, let's start with 2 floors, right? We're going to quickly rename all these accordingly. So what we want is this 2, what does that indicate? Well, if I quickly go to a front, yeah, something elevation view, this is what we have thus far called the crown floor, which is now set to 8. The 2 is actually something that's below here. So in the end, you can say the crown floor is actually 10, 8 plus 2. Or, not sure if that's even the right way to do this. Is that going to be smart? I'm just thinking out loud at the moment. I think you can definitely do that. You just have to make sure that the starting zone here, so this zone plus or up to, I think that one starts around here, because in the end I know we have 128, so there's like 18 floors between, so this is like what, 10? Yeah, so we need to find out where to put 2. Do we include it into the 8, or do we exclude it from the rest that's above zone 9 or the last zone? So let's have a look at what's the way to do that. So, but for now we have made ourselves a parameter that we can use, because that parameter will also play part into this one. So we might have to add a new parameter here, because this is an extrude from that. We might have to exclude that out from the last floor and then just say minus the ones that we're going to be using. But that's a different story that we might come back and fix later. For this to work, I'm just going to copy this first and go all the way here. Now for this, let me do this. We do need our floor height. Can I grab something from here? Floor height. Nope, cannot. So I just go all the way here. I'm just gonna grab floor height. So Control C. I'm coming all the way here. Control Shift V. Where did I put that? Okay, here. Just gonna quickly move that down here. And what we can do with this is we can do a multiplication. Oops. Of those two, so that we have 2 times the height, is about 10 meters roughly. And what we're gonna do now, since we have those, we can reuse that. Let me see. I do want starting one. Yeah, that one. So I'm just gonna quickly say move that plane down. This one, the z-axis. Let's do a minus z because we want to move it down. So we've moved it now down by 2 floors. Okay. And then we're going to do the same trick what we've done here, which is to project a point onto that floor. Oh wait, and they should go here. We're projecting the point, we're not projecting the plane. And what this will give us, I'm just going to quickly turn off the core. We're going to come back here and fix that later. But what I want to do now is we can say a circle. Okay. What are we gonna do? Let's start with a 15 meter radius. Yeah. So if I look at the top, it's gonna be maybe smaller. Let's say the maximum you can go is 50. I think at the end of the day, we might have to come back here and make sure that this is tied to a different value so that we don't go overboard or very small. So just let's leave it at 12 meters. Just know that we have to come back here, perhaps, or not, to fix this. So now we have the starting circle where the, we might want to make this 15 just so it looks better. This is where the point starts to drag down to the floor. So this is why we need this circle, so because we need to know where this point stops. Okay, now with that settled, and the next thing we can do is actually want this starting curve, and we have that. We have that here, I guess, or actually this one. No. Oh, yeah, this whole thing. It's basically this whole thing. How we can extract that curve is we can apply some smart logic, and let me think. So we got these panels. Well, you could play it like this. You could say list item, okay, and since we can now visually see which one you want, we separated that, and just give me, and then you can do a brep deconstruct, okay, and then you select the right curve, which is not that. So you need to probably have to play with which one to select. But a better way would be to, let's not do this, because then we need to select which one we want. As you could have seen, I was not expecting 0 to be there, but apparently it is. So what we can do is we do a sorting process again. We explode everything here. We do a curve evaluation. We're going to move this a little bit down actually. We're going to move that. It looks messy, but if you build in a logic that is solid and sound, we don't have to come back here and move anything ever again. So the logic I want to implement is, you see these points that I've drawn. I want to do a test that say, this point, give me the closest point, and that corresponds to your edge. Because by this logic, none of these will be valid. A potential problem could be these. But as you can see, if you're gonna measure this, this could be in the center though. Or we could do a, let me see. Oh, we could do it like this actually. Let me raise that back up. We could say, for every of these panels, give me the ones that closest. So that will eliminate to this point, right? So that will eliminate all the others. So those will eliminate these, okay? And then we can implement a secondary checking that will give us this curve. So let's first eliminate that first, so we don't have to come back here and do a reverse or non-reverse to select the right panel. I'm just going to quickly clean that up. Yeah, so instead of that, I'll just do area, and then we're going to do points closest. Actually, I think there's a brep closest to point. Might as well just use that instead. Okay, let's see how this works actually. I'm gonna, where's my point? There's my point, so I'm just gonna do this. But what this does is it doesn't give me, well, it does give me the distance actually. Let me see. Yeah, so we could sort this by that distance from these, so that when we do a list item, I'm gonna move this down. Actually, I'm gonna move that down a little bit more. Actually, this one can stay here. Like that. Move this down. Yeah, so that does help. So we don't have to do this instead, because area calculating does compute a little bit more. So if you could avoid that, that would be a, if you could avoid it, please do avoid it, because area calculation does take a little bit more time. So we can have that removed, we can have that removed. The reason why you're seeing this color is because we baked the geometry. That's purely for me so that I can select them a little bit better. Okay. Alright, now that we have that one selected, we can move on to finding out a way to grab the outer edges that we want. I already have an idea. We can use the line, this line that we have here. Right, so like I mentioned, we're going to use similar tactic that we use here. But first we need to do a brep deconstruct from this point, just to get our lines out. I'll just copy from here. So we got that, we'll deconstruct it once, and then we're gonna do a curve evaluation, reparameterized, using a 0.5 so we get the middle point. And then we're gonna do points closest to a curve. Yeah, we'll take that and we'll use for this we'll probably use the original line because that one spans the entire floor. So we'll just take that one instead of the shorter ones that controls the bump. So with that said, we can now sort the distance with synchronizing to the line, and then the same thing, we can now select the lines because we know those lines are going to be these lines are going to be the shortest to that center line that we selected. So now all we do is we flatten this and then we say join curve to create a single polyline. Okay, let me actually remove these so that we can see a little bit better. I'm going to leave the white ones there so that my mouse can still snap to those. Okay, that was a little bit complex, I would say, for something that is for one single line. But what this will enable us to do is whatever happens here, we can be sure that it's always going to work, because we haven't really implemented something that we have to guess the index, or at least I hope we didn't unless I missed something. But the goal of this, as complex as it may sound, the result is always what you're going to be expecting. So it will have little changing of the floors and stuff like that, and the groove will have little influence to how this will come out. So this will give you a little bit more consistency in your script, that you always get the same result, or you always get the expected results. So actually, you know, I'm just gonna give it a name since I'm looking at this now. Inner, I'll say this inner radius. If we want to make it into global variable, we can. All right. Now that we have this, the second thing we want to do is let's do. I actually want curve to curve proximity because I want a point that is going to be on that circle. So I'm just going to do proximity, I believe, curve to curve proximity. So these two there, and what I can get from here is a line. And the next one we're going to tackle is to finish up our shape. But first I want to direct your attention to the reference pictures again of the tower. If I bring up my pen again, there we go. So if you look at the top right, we have this part. When we have this part, now if you look at here closely, there's still a small part that extends a little bit before it closes the shape. So we're going to focus on that, and let me clean this up and then bring back our script. Since we only have the bottom one, we only need the top one, like I showed you in the picture. The best way to do it will be just to create a plane, right, based on what we have, and use the plane's own vector to create that line. And one of the quickest way to create a plane like in our current situation is to create a plane by 3 points, which is if you look at vector and then plane by 3 points. We have 2 points already, this one. We just need the top one or the last one. So we can do an endpoint. From here we can just select either the S or the E depending on which one the top one is. But I don't want to make that choice. I want to create an algorithm or have the script do it for us. So we're just going to do a quick sorting process. So combine those. I'm going to say sort by the Z value because the one at the highest Z is the one that we want. So I'm just going to quickly do this and then reverse that so that I can have my last point. Oh, take that off. There we go. Oh, I flatten. I should reverse, not flatten. There we go. So that we can start creating our points. So this is going to be, I think A is this one, and B is this one. Okay, now that we have that settled, we have our plane directly where we want them to be. We can go ahead and deconstruct our plane. So we're going to deconstruct this plane in order to extract the Y vector from here. So we're just going to quickly do an SDL line coming from that top point, okay, that we've sorted. Direction is going to be that, and then we're just going to enter a value that's from a meter to 3 meter. I'm not sure which one I will need, but we'll see that soon enough. Okay, let's do the maximum. And now we can do a loft. Oops. We'll do a loft. We'll flatten the input here, and we'll take that one. Okay. If your loft turns off crisscross, then one of your curves might need to be flipped. But if you were to follow, like if you made this line from A first, from this point to here, and SDL from that point to there, you should not have to flip any curve. So let me disable that, disable this, and disable this. So now we can play with this 3 meters, like how far do we want that to extrude. So let me try this one. Yeah, that looks actually a little bit too big still. I'm gonna try this one. Something like that looks better in my opinion. Okay, all right. And now we have this part, and the next thing is we're gonna focus on the last part of the video, which is the steel rods. For the steel rods, it's actually quite integrated into this, and we're gonna make use of our circle here. First, we need to might fix that. Let's see curve on point and curve. We want to see how this curve is built in the sense that where it starts. So the start, it seems, is a location that definitely has nothing to do with us. So what we're going to do is we want to move the seam, okay, and move seam. For the move seam, we need a T parameter, which we can get. Is there anything here that give me a T parameter? No, there's nothing. Okay, so we're just going to do a point closest to curve then, because that one does give us a T parameter. So the curve we want to move is this one, and we want to have that point there, and we know it's point B, so we just plug in point B here. We move the T there, and now if I were to do a curve, point on curve, this one, you will see that our starting point now starts where we just finished the backfold and goes counterclockwise. So whether that has to be flipped or not, we'll soon see. All right. What we can do here directly is we do a defined curve, and we can connect that to one of our density We can connect it here actually. But it's different though. So the question is, do we really want that or not? Probably not. But we do want the other curve because that's where we want to connect. So I have to search here and look at, we can actually create, actually let me do a curve evaluate here, and then we're going to do it parameterized. I think this will be 1. 1 will be the endpoint because the way we've built this, you also using the SDL, which starts from the outside and goes to the inside. So that's the way, one way we can know for sure that parameter t at the end will be the endpoint. The reason why we do this is now you can either say, all right, the amount of points you have is going to be the same as here to make it match. But do notice that we have here now this this weird gap. But we can actually see how that looks like first before we do anything else. So I'm just going to do list point. How many do I have? 11, 1. So that I have 11, 1 here, 101 there. And let's try, see what we get. We want to start from the bottom to the top. Ooh, I mean, it looks not bad. It looks kind of cool actually, but that's because we need to flip that curve. So I'm just going to quickly flip it. There we go. I mean, this does not look too bad. The density is a little bit high, and there's something wrong here, but that's because it's connecting there. So we might have to remove that part. And this one, well, it's pretty acceptable. One way we can sort of fix these two is, first off, we need to remove this extra curve because we definitely don't need that. And we can actually do it quite easily using a simple culling. Cull index, and we'll just call the last one by entering here a 0, and we'll do a double reverse. There we go. Then remove that last one. Yeah, so like I said, if you want to fix this part, what you can do is you build a new interpolated line, and from the interpolated line you create your new points. So let me show you. Let's say you interpolate this line, and let me do here, and then you do a curve division based on a number. I'm just going to call this 100 just for now, so you don't need that. And from this you can actually do this, which gives you a little bit more uniform look of your curve instead of what was it, I believe, oh, wait, yeah, now I think I've destroyed everything. Oh wait, this has to go here, and this has to go there. So instead of this, you basically fix the big part over there. Okay, and this you can still control this, or if you don't want to control it, so you can just do it like this. And let me put this here so that you can control it. So you can control the density of it. So maybe we'll go with this. So let's call this then steel rod, actually vertical steel rods density. There we go. So they can play around with that. Also, it's 50. So we'll hide that. We don't need this, and we got this. We don't need that. We don't need that. We can hide that, and we got this one. Okay. Actually, maybe 80. Yeah, that looks a lot better. So you can now pipe this in order to get the steel rod to show. Okay. I think this is now quite a length of videos now because we've done quite a lot. Let me quickly Yeah, we'll leave that on. And quickly get our outputs together. So for example, this one is going to be, let's do a geometry, and we'll call this what do we call this? The crown depths. Does that make sense? We'll just call it something. We just need to name it now. Crown. No wait, crown ramp. Yeah, that's in this one. So, and this is the vertical steel rod, which we can take from that name. So I'm just going to quickly do, since these are curves, we're going to do this, and then we'll, just so the name gets copied. All right, and then we can, what's this? Oh, that part. I actually have no idea what to call this. I'll say the crown backfold. Sounds weird, but and then we have a circle. We might need that, so I'm just gonna quickly do this instead. We're gonna call this inner platform inner platform. It's not a radius. We can get the radius from here. That's easy. Okay. We'll group that first, and we'll give it a name before we end this part, and then we're gonna call this crown inner structures. That sounds weird, but we just need to give it a name for now. And then let me delete that for now. Oh yeah, then my mouse goes haywire because it has no geometry to snap to. Okay, I think we're really near the end. I might just want to add one more part, and that's to, if I can quickly draw this one. And since we have this one, and we know there is a separate platform here that's on this level almost or higher, so we're going to create that. That's quite easy. We have the circle, we just need to scale up, scale down, move it up, and then we have it. And another thing is, we know, or at least you know, that there's going to be vertical steel rods also going this way for the inner side. Of course, this is a really bad drawing. And then we'll try to have a look at, can we defy this backfold? Let me actually use a different color. Can we defy this backfold and actually give it a panelization with this width for, or not, because we're not really doing anything else with this anymore. But definitely want to do the sort of circular horizontal steel beams, because those definitely exist. Because if I quickly get rid of this, go back to the pictures, yeah, so the same picture, you can see that it's quite dense steel, but it definitely exists. And you have the platform here, and the panelization on this side is what I was talking about. So we can see if we manage to do that or not in hopefully the next and final part of this tutorial series. So until then, I hope you've been able to learn something new from this part, and I'll see you in the next one.